Previously, we saw that a curve in the xy plane is the graph of a function if and only if the curve passes the vertical line test, meaning that no vertical line intersects the curve more than once. It's natural to wonder whether there's also a horizontal line test for curves, and if there is, what such a test might indicate. It turns out that there is such a test, and it determines whether a function is so-called one-to-one, as we'll describe in a bit. You see, geometrically, horizontal lines correspond to possible outputs. So when a horizontal line crosses the graph of a function, this means that the function achieves that output. When such a line crosses the graph twice, then the function achieves that output twice, that is, at two different inputs. For example, the power function f of x equals x squared achieves every positive value twice. The value y equals k is achieved by the inputs of plus or minus the square root of k. The value 0 is the only value that this function achieves by only one input, namely the input 0. When a function achieves a given output for two different inputs, then the function fails to define a correspondence between its domain and its range. Indeed, the output that is achieved twice corresponds to two different inputs, so one might say that for this output, the function is 2-to-1. In contrast, a function that is 1-to-1 associates to each output only one given input. In this case, such a function does define a correspondence between its domain and its range, because there is a way of retrieving a unique input from a given output. The graph of a one-to-one function must pass a type of horizontal line test, in the sense that any horizontal line crossing its graph must only do so once. Indeed, if a horizontal line crossed the graph more than once, then that output would be achieved by two different inputs, making the function fail to be one-to-one. For example, any linear function with a non-zero slope is one-to-one. This is because the graph of such a function satisfies the property that any horizontal line intersecting the graph touches the graph only once. As another example, any exponential function that's not constant is one-to-one as well, because the curves of exponential functions also pass the horizontal line test. As a non-example, we saw that the power function f of x equals x squared achieves every non-zero output by two distinct inputs, and so this function is not one-to-one.